All right. Hello, everybody. Good afternoon. I am Laurel Bellman, and I am here with Isaac Knoflachuk. Yes, I think I got it right. Who will be presenting his session, Keeping IT Wheel with Transportation Services. After Isaac's session, we'll have some time at the end for some Q&A. So please put any questions or any comments in the chat, and we'll go ahead and get started. Just to note, we are recording this session, and an accessible video will be available for viewing on the IT Professionals Conference website next week. And so with that, I'm going to turn it over to Isaac. And Isaac, if you wanted to go ahead and repeat your question to the audience, I think that would be pretty cool.
Sure. So forthcoming is the answer, but if you guys just want to throw in chat, how many network devices do you think there are involved in one lane of exit, one exit lane in a parking facility on campus? How many network devices, how many IP addresses? We'll get to the answer in a minute. Thank you, Laurel, and also thank you. So I was trying to think of a good pun for the title of this, and I outsourced that to Laurel, who took it to some colleagues, and they came up with this keeping it wheel, which just an S-tier pun. It's so good. Thank you so much for enriching my presentation. So yeah, with that, I'm going to jump right in. Okay, so a little bit about me before we get started. So my name is Isaac Knoflachuk. I've been on campus for about 10 years. I've been at Transportation Services for 3.5 years. Just personally, I'm a hobby woodworker. This is a table I finished recently that I'm pretty proud of. I feel a little guilty about this slide because I'm like, here's my family. They're pretty cool, but do you see this table I made? I'm so proud of this table. But no, this is my family. I drive a funny little car. I'm pretty into mindfulness meditation. I've got 500 some hours on the cushion. Here's another woodworking project. Yeah, so that's me. What is Transportation Services? So Transportation Services is an auxiliary, meaning we don't get any state money. We're entirely self-funded. I think most people think of parking and permits when they think of transportation services, but we also do special event coordination. So like this time of year, it's a lot of summer camps and events, conferences and stuff. We also do all the big Badger football games, Badger basketball games. We assist with all those special events. Maintenance is a huge part of what we do. It turns out parking garages that are run over by cars all day, every day, and bake in the sun and get frozen, salty snow melt in every crack, frozen year over year. There's a lot of maintenance involved in that. So that's a huge part of what we do. We do enforcement, coordinating routes around construction. We consult on a lot of that type of work, citation payments and appeals. Also like multimodal options, so like park and ride and things like that. We assist with transportation planning for the campus community. So kind of just some quick facts about us. There's about 200 employees. That includes a lot of the students who do the Safe Walk program, who will walk students around campus after dark to make sure they're safe, as well as the special events staff. There's a lot of limited staff who just help out during special events. We do a lot of credit card transactions in a year. It's a pretty good mix of card present, like at the customer service desk downstairs or at the kiosks, or card not present via our e-business platform. We do a lot of internal transactions. So a lot of departments have parking permits that they buy. We sell to internally. Also validated parking, where you might have the cost of a visitor parking transferred onto your internal funding. So we do a lot of that, a lot of citations in a year, a lot of active bus permits. We manage that system for UW and UW Health. And then active permits, there's a lot of different types of parking permits, but the main ones are base lot and flex permits, and we have a lot of those. It's a snapshot of what was active at the time of putting together this presentation. Okay, so parking. Parking, I think, is especially interesting, and it makes me think of Thomas Sowell, the economist, defined economics as the study of scarce resources that have alternative uses. And I think that really hits for parking, because every parking stall on this campus could be a research lab. It could be a classroom, could be a green space. There's alternative uses. But the problem is, if having all the best classrooms in the world doesn't do you much good if you got to be like airdropped into them. So campus tolerates some parking, but not much. As you can see, there's less than 13,000 stalls for a community of 75,000 people. This is, I'm told, the second lowest ratio of parking stalls to community in the entire country. I guess University of Seattle just barely edges us out, but for the most part, campus chooses the alternative uses. But where we do have parking facilities, you can understand why we want to be a good stewards of that resource. There's a lot of rules around parking. There's a lot of enforcement. And, all of this is built around being good stewards of that resource. And one of the ways we manage parking is, this is an acronym you'll see a lot during this presentation, PARKS. So at our parking ramps, our gated facilities, we have a park system. So parking access and revenue control system. This encompasses the hardware and the software involved in that system. So parking access, think permits, the various credentials that get you access to the facility, and then revenue control is more like pulling a parking ticket and then paying at the exit. So this is one of the ways we manage the limited resource of parking on campus that we'll talk about a lot more.
So we have a quick question in the chat. So do
Yeah.
you sell more base lot permits than total available stalls?
Yep, we do oversubscribe. There's different numbers depending on the facilities. We could talk more about that afterwards, but yes, we do. Okay, so quick word before I dive into what Transportation Services IT is. A quick shout out to our campus partners. So Transportation Services, the IT department in Transportation Services, we don't do desktop support. We rely on Do It departmental tech support. We don't have developers in-house. We rely on Do It web and mobile solutions. Our entire unit is heavily reliant on our campus partners and their expertise, which allows us to focus on adding value to what Transportation Services does. So Paul Simon may be an island, but Transportation Services IT is just heavily interwoven into the campus community. And so if there's a takeaway, I think that's one of the reasons why we're able to do any of the things you'll see in this presentation, why we're able to meet any of these challenges is because of support from our partners. And I think that's just a good way to be on this big and interconnected of a campus. All right, so Transportation Services IT specifically, our IT department, I kind of think of it as having these two different kind of units. So we have kind of hardware and infrastructure on one side. So we have two field technicians who are the ones who, when there's a gate issue, jump into one of the little toasters and zip out to the parking garage and try to solve the issue. In that area, we also have an engineer who does the higher level support issues, but also manages upgrades and do features and maintenance, stuff like that. So there's the hardware and infrastructure side. On the other side, we have two business analysts and a GIS specialist, a lot of maps in transportation. So we have a GIS person handles that. This group does more data and automation. And then we kind of combine to do the application management. We have one main vendor application, which most of this presentation will be about. And we kind of all share that responsibility. And if you'll permit me just a moment of immodesty, I have the best staff. They are just incredibly dedicated and just smart and creative. Whatever God's award the good hires, I've been incredibly lucky in this area. So thank you if any are on the call. Okay, so here's kind of the world we'll be swimming in for the remainder of the presentation. Our main parking vendor is called T2 Flex. It's a big Oracle database, and I'll qualify that by saying this is the biggest Oracle database I've had experience working with. I know in an audience this big, a lot of you are probably like, that's cute. That database is big. But it's for me, very large database. And I put the entity relationship diagram down here just so you can see, like, I have citations as kind of one box. It's actually many boxes, many tables related. But you can see in this database, we have tables for citations, for vehicles, financial transactions, the point of sale stuff is in there. Hanging off of this database is an e-commerce platform called Flexport or eBusiness. If you've ever bought a parking product online, that's what you've used. And then these three green boxes kind of align with the three challenges I'll be going over in this presentation. So there's permits, parks, the gates, the incidents, the transactions, and then the entities, which are the customers or users that we have in our database. So this is kind of the background, and now let's jump into our first challenge. So I titled this Entropy and Ecology. I apologize if I'm using these terms imprecisely, but I was thinking, like, entropy, it's like there's a lot of ways you can arrange a bunch of particles. Most of them are not a functioning parking garage. So the tendency will be to regress to the mean of not a functioning parking garage. So that's one thing we battle. And then ecology, you think the weather, here we have a bird's nest on an RFID reader. Nature is fighting us at every turn, but also like cars, people, the environment around our parking equipment is also a challenge. So let's jump into that, my trivia question from the beginning. So this is the mug shots, the lineup of our parking equipment. I don't think it'd surprise anybody if I told you like this isn't like a thing. This isn't like there's not a, you don't plug it into a power outlet and stick an Ethernet jack in the back and have a functioning parking gate. It's a modular system. Most of these are the same with just different components swapped out, but there's a whole variety of modules that go into these. And just a quick diagram. So the answer to the question earlier, there are 5 network devices in one exit lane of traffic. So this is kind of a rough diagram of what is in the columns. So we have a credit card reader, and that has its own dedicated network connection. That's because we use what's called point-to-point encrypted credit card devices. So it encrypts the card data on the device before it ever touches the network. And as such, it can send credit card data over the public network. So that's one network device. And we have this V4 and this industrial PC. I kind of think of this as like an Arduino and a Raspberry Pi, but like industrialized. So the V4 is kind of like a general purpose circuit board on the network. The IPC is just a Windows 10, like a ruggedized device that is literally mounted inside the column. So those are both network devices. This runs a little piece of vendor software that reports to the database. We have an RFID reader. So all our gated facilities, the permits have an RFID tag built into them. This RFID reader will pick it up and relay it through the system, find the permit that matches that RFID tag. And if you have access to that facility, it'll open the gate. If not, it'll tell you you do not. So that has its own network device, is on the network as well. And then the intercom board. So if you have issues, you can push the help button and you'll call a dispatcher who's located in lot 75. That intercom board is basically like a closed circuit, like a stub VoIP network. It's its own server and 50 different VoIP devices all connecting through an intercom, a VoIP. It uses IOIP's slightly different protocol, but and that connects to we call a master station in the dispatch office. So there's 5 opportunities for it to be DNS, 5 network devices that could have issues. And here we rely heavily on Do It Network Services and formerly AIMS, I guess now it'd be the SIMS group, to help us manage all these little stub networks because these aren't in one place. They're all across campus, different network devices. So that's one point of failure. Then kind of hanging off of that, there's off the V4, there's just a touch screen that you use to interact with the column. There's a touchless sensor, so you can hold your hand in front of it and it'll issue a ticket without you having to come into contact. There's receipt printers, there's a prox reader, so you can do NFC or the WISCard's HID, I think, HID. You can use that as a credential. We don't really use that much today. There's a barcode scanner to read the QR code on the tickets. So these are all separate modules that could go bad on any given column at any given time. And then there's the gate barrier, the separate column that has the big arm that goes up and down, granting you access or not. So a lot of different pieces and a lot of opportunities for something to go wrong. And these gates get used, turns out. So this is all the parking facilities we have on campus. Here's a count of transactions, meaning an entry or an exit from a permit or from a visitor, so just a pulled visitor ticket. So grand total, 4.3 million transactions over the past year on our parking equipment. So a lot of opportunities for one of those components to run into an issue. 2 caveats about this number. 4.3 million is successful transactions. So anytime something got screwy with the system, it wouldn't have logged this. Then you notice, so up here, the hospital ramp, lot 75, you notice the visitor spot is blank. So I could have done an entire presentation on this challenge, but lot 75 is actually like the unholy union of 2 completely separate park systems. So for permit access, it uses the same parking system as everything else on campus. But when you pull a ticket, you're actually interacting with a completely separate park system. They're basically hooked together with baling twine. And the visitor system is harder to get data out of, so I just didn't bother to get the visitor count. But this is probably 500,000, 600,000 visitors additionally. And like I said, the caveat of the challenge of this whole separate system, we're actually starting a project to get down to one system starting next week. We should be unified across campus. So if I do this presentation in another year, I'll have better data. So anyway, a lot of components, a lot of opportunities for the components to break, and then getting into like the environment around it. So turns out it gets real cold in Wisconsin, but it also gets real hot. We get snow, we get rain. Most of our equipment is in open air, but has a cover over it, but some of them don't. So our parking equipment needs to function in all these environments, and our staff have to go out in all this environment to perform maintenance and resolve issues with the gate equipment. So the weather's fighting us. We have a lot of people on this campus, a lot of visitors. Some of them are not always making the best life choices. So many times a year, you'll see somebody just be like, I wonder what happens if I lift this up, or, somebody's angry and just karate kicks the gate or tries to climb on top of it. So a lot of fraught interactions with our gate equipment. This you see, unfortunately, a couple times a year. This is when they'll park maybe a little too far away from the column and they'll be reaching way out to push the button and their foot will slip off the brake. The car will start creeping forward. They stab their foot to try to hit the brake, but they hit the gas. And, we put these bollards in front of the gate equipment to try to protect it. This guy just threaded the needle. This customer just threaded the needle and smacked the gate over. So we get a few of these a year. And then like nature, this is 27, actually fairly recently, we had a bird's nest, robins, right on top of the RFID reader. And this thing beeps every time it reads a ticket, every time it reads an RFID permit. So these birds constantly all day are beeping. We were like joking that they're going to like incorporate the sound of that beep, the babies, into the bird song. So lots of conditions that are challenging, a lot of interactions that are challenging, and then just a very complicated, complex components system with a lot of components that could go wrong. So that's kind of the parks challenge. The second challenge I'm going to discuss is so many users, and this isn't just like so many users, this is just so many users. We have so many users. So I'll jump back to this diagram, which I showed earlier to kind of orient us. So there's this entities customers table that these all go into in the system. So, but the question is, how do they get in? How do we get the entities, the customers and groups into this table? So kind of up at the top, the identity and access management services, I'm sorry, identity and access management group, they provide this service, Person Hub, which I would love to see one of these sessions on Person Hub. Like, this thing is amazing. I'd love to learn more about how it works. I suspect black magic. But what this does is it reaches out into the State Historical Society, into the UW Hospital and clinics, and into the student and staff areas of UW Madison, and pulls all the data into this one central data source and normalizes it and has appointment data, a lot of rich data about all these different sources. So that just exists for anybody to consume. We have an application called Tron, which is developed by Web and Application Management. Getting too late in the day, I'm messing up my acronyms. The WAMS group puts together for us. So this does two things. So one, it reaches into Person Hub and checks what's in our entity table in our vendor software and pushes, it basically syncs everything across. It also, we have this very important field in our vendor software called the subclassification. You can only have one subclassification on a user or a group. And that subclassification is what the software uses to allow you to do different things, like what permits you have access to buy, what payment methods you can use, even the rates you pay for your product are all determined by this subclassification. So Tron has all this logic built in to set that subclassification field for us. So it's reaching into Person Hub, looking for duplicates, syncing everything up, getting name changes and stuff like that, pushing it across. But also, like, if somebody's a student and a staff, are they the student subclass or a staff subclass? If they have an appointment at the hospital and at UW Madison, what's their subclass then? There's rules built into Tron that help determine that. Furthermore, Tron has a separate hook into the UW HRS system. So we have a system in place for reduced cost permits. So employees who make below a certain salary threshold are eligible for reduced cost permits. Tron goes into HRS. It doesn't move any salary information across, but it looks and gives a thumbs up or down if the salary qualifies and makes an adjustment based on that. UW Hospital and Clinics also offers reduced cost parking. They just give that to us in a flat file of all the employee IDs and whether or not they have access. So Tron also consumes that flat file, pulls that in, and uses that information to set the subclassification. So Tron is incredibly powerful way of setting this information in our vendor software users table. Aside from that, there are other ways for data for users to get into our table. That Flexport, that e-commerce platform I mentioned, you can just go out there and make a user account. If you get a citation and you have no affiliation with UW Madison, you might want to create a user account so you can pay your citation. So that's an issue because, or a challenge because, so 10 years ago, I might have created a paid a citation and used my email to set up an account of like my old My Little Pony fan 32 at Hotmail. and I paid a citation with that. A few years later, maybe I got one and I used my much more professional Isaac.Knopflicek@gmail. And then a few years later, I get a job at UW Madison. I'm now in this table 3 times with different email addresses. And if you search for my name and you see those 3, it's not immediately obvious if it's the same person in a lot of cases. So duplicate records is a huge challenge in this system. Additionally, there are situations where we have to manually create users. The groups is an example of this. If there's a new Department of Experimental Transportation on campus, we would just manually create that entity in the database. And then if you get a citation and you do not go into the e-commerce platform or do not pay it, we have a hook into the DMV where it can actually pull the user information associated with the permit that we cited, the plate that we cited, pull that information into the entities table. So that's also in the background generating more users. And so the net effect of all of this is a lot of users. Anybody who's ever done any user management, please look away. This is going to be gruesome. We have 638,000 entities in our table. So I completely am open to the possibility that some of you out there are like, that's cute, that's not that many users, but this is so many users. So it's a mess. And we've gotten the number of duplicates way down. It's compared to what it was, it's fairly clean, thanks to the work by WAMS and Tron, the Tron application. So just diving a little bit into what some of the users are, the demographic information. So here's a classification and then the subclassification, and then just a count of how many users have those. So we have 35,000 UW employees. You can see another thing Tron does for us, it looks at how many times you get paid in a year. Are you a 9-month employee who gets 18 paychecks in a year? Are you a 12-month employee who gets 24 paychecks in a year? And then it also modifies that based on your salary if you're reduced cost eligible or not. It looks up a maritime, categorizes them appropriately into an maritime subclass so they can get their maritime permits, their special credentials, state historical society, hospital, reduced cost and regular. So a lot of good employee information. For students, most students are just don't really have any permission for parking, but we get them in here anyway. Tron is setting the subclassification based on if they're a graduate or professional student. Doesn't really use that information, but again, we're classifying them appropriately. And then if a student wants to apply for parking, they have to go through this separate process to demonstrate a need for parking. Like I said, most of them just by default aren't eligible for parking. But if that happens, then we manually switch the subclassification to student eligible for parking. So Tron has to know to ignore this subclassification. We manually set it. And then you see all these moped lots. This is interesting. So students who live in a residence hall are eligible for to buy moped permits for the moped lot associated with that residence hall. So if I'm in Og Hall, I am eligible to get if I'm a student in the residence hall, Og Hall, I am eligible for a 605, 610 moped permit. So it's also looking at residence hall assignments and assigning subclasses based on that information as well. So just a ton of complexity, all handled for us by this Tron application. And then finally is groups. These are almost all manually created. Departments buy permits, departments do validations, as I mentioned earlier. Most of the departments are UW Madison departments. You can see we also have some hospital departments, some state and UW system. Also vendors, we have like Gordon Flesh or Johnson Controls, some of the vendors who are on campus a lot purchase parking products too. So we maintain information for them as well. So that is the big mess of entities, groups, users in our vendor software. And on to the last challenge, which is I called the politics of parking. And you'll forgive me, I got a little maybe indulgent when I was setting up the slides in this last section. But so parking is a scarce resource, and prioritizing it is a big part of what we do. Everything in this section is done by another WAMS developed application, the paths. So if any of you have applied for parking in the last, I think it just opened a few weeks back, it ends tomorrow maybe, apply for parking if you hadn't. That PAS application is developed by, and actually just redeveloped this past year by the WAMS team. So all this logic is kind of baked into that application that we'll discuss here. So I think the easiest way is to kind of have a simplified example of how this works, how parking is prioritized on campus. So imagine that we have this collection of users who would like to apply for parking in a specific parking lot. The way our vendor software is by default designed to work, it's just like a first come, first serve waitlist thing. So Admiral Akbar got up at 6:44 a.m. He got his parking applications in, so he's first on the list. Captain Nita came a little later. Vader edged out Palpatine. So This is perfectly passable way to do parking. The problem is I don't want to tell Chancellor Mnuchin that a bunch of students got on at midnight and bought all the Lot 11 permits, and so you have to park a mile away. We need a way to prioritize the parking applications. And how do we do that? Strict question. We don't. What we do is we arrange parkers into these parking units. So here in our example, we have a Rebel parking unit and an Imperial parking unit. In real life, CALS, the law school, LNS, UWPD, I'm an FPNM, DoIT has their own. These are units in which the individuals who apply for parking are prioritized by a unit transportation coordinator. So we don't really know or care, and we do care, but how each unit prioritizes the individuals in their parking unit is kind of doesn't matter to us. It's up to them. So I know, like when I was in CALS, I believe they actually subdivide the list further so that the departments each prioritize their own department, and then they roll that back up somehow. I think the law school has like a point system where they award points based on your educational attainment and tenure, all different ways that the units do it. We don't honestly have that much visibility into how some of them do it, but the point is it's up to them. We're not, transportation services is not deciding. So here we have our Rebel park units, and here's been prioritized. Again, I don't have any visibility into how, but one thing I would like to note here is that the parking units are two different sizes, right? We only have 5 people in the Imperial parking unit and many more in the Rebel parking unit. And since these people are all applying for the same parking lot, we need a way to shuffle these together to evaluate them all as to get them all in the same wait list. So you might think the easiest way to do that would just be to take 1, 1, 2, 2, 3, 3. But what happens if you do that is, at the top it works out. We get, Mon Mothma with Emperor Palpatine seems fairly comparable. When you get down here, we have Stormtrooper TK421. The Empire is just out of employees. So we have the Stormtrooper above, generals and Jedi, just by virtue of that unit being smaller. So it's not really an equitable distribution. We need a way to normalize these two different sized parking units together. So what we do, and this is it involves some quirky maths, bear with me. So what we do is we look back at the past 3 years of parking and how many parking offers were made to each unit. So here's the Rebel parking unit, and this is year 8 BBY, before the Battle of Yavin. So in this year, they had 7 offers extended to this parking unit. In year 7 BBY, they had 9. Year 6, they had 8. So we average those and end up with an OTU, we call it, the offers per transportation unit, of 8. So this is the number we're going to use to normalize the data. For the Imperial parking unit, they've just had 4 every year, so that average is real easy to 4. Now this, the formula we use to normalize this is from this UW policy. This is actually set in 2001, so that predates, I think, everybody in transportation services. This formula may have been handed down by Lycurgus. I don't know. It's old, but it kind of works, and so I don't know that anybody's interested in touching it. But I'll show you on the next page kind of how it works. So we have the priority number. So Senator Mon Mothma is priority number 1 for their individual unit. You also are starting to call it the local priority number for their unit. Then you times that by 100 over for Senator Mon Mothma, it's 8. And you get this global priority number, we call it, of 12.5. Bail Organa is 2 times 100 over 8. And Palpatine is 1 times 100 over 4. You get 25. You see what happens when we do these maths and then sort. You get this nice banding, right? 2 Rebels, 1 Imperial, 2 Rebels, 1 Imperial. And now we have Stormtrooper TK421 down by Porkins, which seems a little more equitable. So that's how that works. That's how we normalize this. And this scales, right? You can have, obviously there's many more than 3 units or 2 parking units. There's something like 30 across campus. So we can use this same formula to put everybody together in all the different wait lists. And then kind of the final piece of this puzzle is, so now we have this number, we need to convert this back to a timestamp. So you remember our vendor software just wants first come, first serve wait list. So we basically divide this number by 200 to get it to a decimal, and then we convert that to a timestamp. So just with 0 being midnight and 1 being 11:59, we convert that to a timestamp. So Mon Mothma is 1:30 a.m. Bail Organa is 3 a.m. And this way it organizes itself into a nice wait list, which when we plug that back into our vendor software, we're actually inserting these requests and setting the date at the time of insertion. This gives us this nice prioritized list. So what our permits manager does is says, okay, I think I can award 10 permits to this, to space lot 20, and it'll award to the top 10 the highest priority based on the unit's priority and this kind of means of normalizing and grouping the multiple data. So that is real fast kind of what we do to prioritize parking on campus. And then kind of last but not least, so that is my third and final challenge. I just wanted to do one more shout out to our campus partners. Again, a lot of this is the WAMS team, but a lot of support from all these groups across campus. We could not function without them. So that is my entire presentation. Thank you very much. Does anybody have questions?
I think that was amazing. And I loved your analogy with the Star Wars and parking. It was fantastic. I actually followed it, and I'm not a math person, so that was wonderful. Thank you so much for this fantastic insight into transportation services. It's one of those things where you're sort of like, well, I'm assuming this is very complicated, but you don't really know how complicated it is. Really awesome. I don't know if there's any questions. We did have one quick one, which was about prox readers. Do the prox readers in the stations, do they read WIS cards?
So they can, they're not, so you would scan it today and it'd just be like, I'm reading this number, I don't know what to do with it. So I haven't found a good way. And if anybody's on the WIS card team and wants to chat more, I've had a few conversations with them. What we need to do is get the number that the WIS card that is read when you scan the WIS card, and get those and then like associate that with a permit in our database. So it could be used. I would love to explore that further, but today it doesn't. I mean, I just for fun have my WIS card set up for a permit, but it's not something we have figured out a good way to offer to all of campus yet.
Awesome. All right, well, if anyone else has questions for Isaac, please feel free. I think you're okay with people emailing you with any questions. Oh, one more question here. How are ties for the global priority number decided?
You know, in real life, I don't think it happens that much given these numbers are all much bigger than my example, but I honestly don't know because I saw that in my example, we had 2 3 PMs. So that's actually a great question. I don't know what our software does in a tie. It's probably whichever one's injected first. So just if you do unit 1 and later you did unit 2, it would probably just put it behind. But yeah, that's a good question. And I don't think it happens that much in the wild.
That's good. All right, well, I want to thank all of you for joining us, and thank you, Isaac, for this fantastic presentation. It was really great. So we have lots of great sessions coming up tomorrow, and so we look forward to seeing you all. And this recording of this session should be available sometime next week. So if you enjoyed it or want to just revisit it, you can check it out next week. So thank you very much. Bye.
Thank you.